Hello and welcome to Database Design Chat number 9. Coming to you a little bit later than I'd hoped. I'm trying to do these every week. Probably try to do 2 this week. Last week I had a little bit of a down week. I was really tired, and I did record once, and the audio was crackly. And hopefully the audio will not be crackly this time, or you won't see this. So it won't really matter. I'm Dr. SQL. I'm not exactly that floating head. My head's a little bit different than that, but David Neal does such a great job. I love that picture. If you want to know anything more about me or get any of my slides or anything like that, which I need to start putting the slides up for here for these sessions, I'll do that sometime this week as well. Go to linktree/DRSQL. That's where I keep all my stuff. My slides will be on GitHub, the whole 9 yards. These are on YouTube, you know that. And I do some other stuff, Disney, Dollywood. I like theme parks as well. It's part of my problem in life. All right, so the first one, reform. This topic is very fundamental to getting a good design of your database. Okay, we're going to start out. We're going to say you've got to do everything that we covered in relational form, and I will say that while most of the most of the normal forms we'll talk about, you don't necessarily have to be in the previous form. Relational form is, you need to be there. You need to have all your rows unique because, you can't go fetch them. You need to have a key. You need to have some way to go know how to address a row. And you need to make sure everything, you're treating it as one row has the exact same number of columns. That's the fundamentals. Ignoring things like XML or JSON you can store in a row. Okay, so once we had that down, we want to make sure that data is broken down in its lowest form. We want to make sure that you're treating each row as one thing. So you don't have a column which has an array in it, which is payment 1, payment 2, payment 3, payment 4, payment 5, whatever. You don't have that sort of thing. You don't have columns which mean different things. So which means more than one. So you don't have payment 1 column, payment 2 column, payment 3 column. That starts to get into the variable number of columns, and it's also considered a repeating group. Both of those are considered repeating groups. We want to talk about things being atomic, basically broken down to its lowest form that you need to deal with. It's an atomic. You take a molecule, you break it down to its atoms. That's good. This is really good for data integrity and performance. The faster, the less you have to break data into pieces as you're dealing with it in a relational database, the better. You don't have to go, start parsing out things and give me the third value in this string. And the reason this is good is because that's how indexes work. Indexes will work best on the leftmost columns. We'll talk about that in a second. And we'll look at a few examples. But this is very fundamental for just getting their data right. Not having to parse values out and update the third common limited value in a string is just so much easier if you can go to a column or go to a row and fetch that value. And it's faster because that's what the engine is expecting. All right. Atomicity means your data is represented in the most granular way possible without losing the original characteristics. Now that without losing characteristics is something that was right over the head of a lot of early designers, because you'll think, I've got a value, Lewis Davidson, Mr. Lewis Davidson, Mr. Lewis Davidson Esquire, whatever, MVP, whatever you want to tackle in the end. You've got this value. I need to break this down. Now, breaking this down into pieces relies on you breaking it down to the number of pieces that a user will use. If you make it Lewis Davidson, you make 2 columns, and you throw out the other data, that's not good enough. That's too far. If you make a space for Mr., you make a space for Lewis, you make a space for Davidson, you make a space for the prefix, you make a space for the middle initial. I'm not telling you that one. That's middle initial or middle name. You make that's good. Lewis as a value stuck together, those 5 characters have a meaning that means something to someone. If I want to have a column then for L, O, U, I, and S, well, first off, most people don't have 5 characters in their names, right? We have multiple values. So that may actually turn into a row. So a row for your first column of your name, low for the second column of your name. That is almost certainly not the right design. keep that in mind, that almost probably not the right way to do it does never means it's not the right way to do it. There is a realistic chance that you might have to be writing some query that counts the number of times the letter O is in names, and that's the only purpose of your database, right? Then that's a perfect design. You put one row per value in a string. You have an LOUIS DAVIDSON in the name. You have columns that describe that this is the first name and this is the first column of the first name. This is the second character of the first name, not column, character of the first name. That is a perfect design for somebody's design. And that is one of the things that you really have to be careful. I've talked about this numerous times. We go back to some of the first episodes. Requirements are king. What the customer wants to do with the data is more important than what you as a designer think they should do with the data. Right? So it's just like physics. If you break down a value, you break down a molecule of water into hydrogen and oxygen, that's no big deal. You can put it back together. You can do all that in your local lab. If you start breaking the hydrogen atom into pieces, that's kind of where atomic energy comes from. And you don't want to do that in your home bathroom chemistry set. It's just bad. It's a bad idea. So let's get an example. I want to store information about books, and I want to have a key, the book ISBN number. Every book has an ISBN number. It doesn't look like that, and they have different versions of it. But let's say we're storing one of the ISBN numbers. That's the key. That's how we want to fetch our book. Great. Book has a title. Books generally have one title. Don't get hung up on that. There's possible chances you need to store alternate titles, maybe for different languages. Maybe you have a primary title and secondary titles. That's, books usually have one publisher. That's, again, I'm not going to go do, I know I'm going to stop doing that. But the fact is, for the general typical case, books have one title, books have one publisher, books have more than one author. Okay. I'm working on a book right now. I think we're going to have 5 or 6 authors. I've worked on books with hundreds of authors. That was fun. But, lots of books have more than one author. So how do you store that? Now, if you're the user, you find a way to store this data because you've made it improper for the customer. Now you've got 2 rows for the same, and this is a real example, by the way. This is not made up. I've seen this done. You get this dash in one, and now if you want to work with this data, you have to make sure you know the actual format of an ISBN number. Part of this is just bad design in terms of formatting the data so people can't put in more data. But part of this is bad design because you didn't think, hey, the customer's going to need to do this. This book may have more than one author. Now, users don't always go the same way, and maybe you fix the format and they put in the author column, and it's Jessica, Lewis, or it's Jessica and Lewis, or it's Jessica and Lewis spelled out, or Indy Lewis, because that's how users are. They're fabulous people that make your life worth living and not worth living at the same time. I mean, I do it to myself. I build designs for my hobby databases for my pictures, and I do stupid things. And when I'm the designer, it seemed like a really good idea. When I become the user, I'm like, what have I done to myself? Why am I doing this? This is so hard to work with and rework it. Now, what's even more unpleasant about this is that not only would they do that in the author column if it happens to be text, it probably isn't text. The author column is probably a foreign key to the author table where you have author details. Now, that means that this can't go in that column, but there is a description column, and they've added a little bit of their own JSON format, and they've put the extra authors in there. Yeah, isn't that awesome? Users are just the greatest. So let's not do that. Let's find the right way to do it. So another typical solution, and this is a very, very, very typical solution, is to add another column for author 2 and author 3. One of those books that I worked on that had 50 authors, we had 5 editors, and some of the systems that we were sending books out to be sold only allowed 5 authors. So the editors got to be in the author column, which was kind of cool when the second book came out, and I was one of those editors. But the first, it's not cool that not every author can be listed on the book. So that's not cool. What we want to do is add another table. This table is books. This table is authors of books. Now, the author of the book can be repeating, because if we want to have another author, we just add it. Now, Lewis is an author on the book. Now, what this does is it breaks things down into this atomic unit that you might want to do things with. I want to add more data. I want to tell what that author's contribution is of the book. Instead of Jessica being author 1 and me being author 2, even though I wrote the book and she wrote a chapter in the book, then I can swap it around now, and it doesn't matter. It goes back to that order should not matter. You shouldn't be reading anything into based on the order of things that are showing up in the database. So now we're good. Now I'm the principal author as a contributor. This thing about normalization is you're trying to break things down into chunks that mean one thing, and every attribute means something about that attribute. That's going to be the common theme when we talk about second and third normal form even more. And even when you get into fourth and fifth, those normal forms, it's all about making sure that every key value says one thing, and every one of your attributes says something about that one thing. And adding more pieces to that is what really makes it great. When you come along and you realize that you need to have author contribution type, you don't have to do something like I had to do it in an example I'll show you in a second. What you want to do is end up having these tables. So in reality, I'm going to have an author table, and that author table is going to have first name, last name, their author number. I'm probably going to have a surrogate key. We'll talk about surrogate keys later. I typically do have a surrogate key for security, for not repeating data. When you're having to delete data and obfuscate data, it's so much easier that way. We have a book table, and it's got the ISBN number, and it's got the title and the publisher. Here I'm allowing one publisher, but I'm defining the publisher based on the book. And now I want to have the book author, and it's the intersection of book and author ID. So I define these pieces at their individual levels, and I can add more bits of data, like when did they become an author? When did they become an author of this book? How much did they get paid for this book? All those kind of things can be now added naturally. And if I need to add, different parts, I can do that. If I need to talk about pay, sometimes you get paid more for the first book. You get paid less for the first books, and then more for later books, so they can get back their tiny advances faster. All right. So the sad reality is sometimes you get saddled with this. Somebody's designed this. You're the next designer, and someone has built this email 1, email 2, email 3. They've allowed only three emails, and it's perfectly acceptable to have a 3 email limit, right? Limitations are not a problem. Business rules are never a problem for your design. But even if you say there's only ever 3, even if you say there's always 3, if you say there's always 3, it's okay in the normalization structure. It's okay to have 3 and always 3. But what happens is somebody goes, we need to do more with this email. Now we need to capture the status of emails. We need to capture, the type of email, and the private. Can this be used? And you might say that goes on an email, and that goes in an email table. Well, possibly, that's a definite possible solution. But an email may have different meanings for different users. You may have the same email shared by 10 different people. And for persons 1 through 6, it's used a certain way. For 7 through 10, it's used for people a different way. An example, if you're a marketing kind of place, or you're sending out subscriptions, there are some places like halfway houses where people can't actually have email, but you can send them email, and they can print it out and hand it to them as a piece of paper, and they can reply via paper, And that's one of the status, maybe output only, input only, disabled. I mean, there's all sorts of things you may need to do based on this type of database you're building. Not every email fits the same mold, just because that's the way it is, right? Fun stuff. Okay. So the where you start to see this in performance big time, other than having to maintain this, like when email one is as archived and no longer used. Some people are not going to want email one to be disabled while email two is enabled, because that whole positional thing on the UI just confuses people and they don't really see the whole disabled. So you need to flop that around and you're just updating data all over the place. All right, so the performance here comes down to how the relational engine works, and particularly in indexes. I want to search for someone named Davidson. How do I do that? Well, I have to go find people whose rightmost characters are Davidson. Indexes work from the leftmost bit and then over. You're working with sorted data. Sorted data typically with the leftmost value when you're doing like or approximate searches. So I can't go into a structure, sorted structure, and find Davidson. I can find Lewis. If all your searches are on DRSQL or Lewis Davidson or K.E. Klein or Sequel Mal or Paul Nielsen or, all of their first names, okay, we're okay with this. If all the time you want to search, you would search for Lewis Davidson. That's totally fine too. If that's the 99, 80, at least 80 percentile, right? That's fine. But what happens when you want to search for somebody with a last name? Well, that's where this structure falls down. And if you want to search for things in their individual parts, you need to break it up individual parts. And let's be even more careful, because like I mentioned earlier, people's names have suffixes, prefixes, middle names, lots of prefixes. If you really want to do a proper marketing type database, where you're not going to stick to this kind of English 3-part name that Americans at least are used to. You need to have a structure which will allow you to have infinite number of names. Nobody has infinite number of names, but if you were to set it at 20 parts, you might end up with someone with 50. I've never seen it, but I've heard this. These are theoretical things. Having limitations based on just random feelings doesn't matter. Sometimes you may say, oh, wait, we have a limitation of 50 characters or 100 characters, something for mailing. Something you may have to limit the number of characters. And that's an artificial, realistic thing you may have to do. And you may find that this person who wants to donate millions of dollars to your company, but has a name with 500 characters, you'll find the way. You won't say, nope, sorry, go away with your money. We don't care about your money. Give us 3 names or get out. Right? We're not going to do that. We shouldn't do that. Shouldn't even start that way. Should be inclusive with people who have different things in their names. We want to break this down to individual parts. Now I can search for Davidson, I can search for client, I can index first name, last name, first name, last name, username, full name, any sort order you want. I can start with that, and then I can search for those values and get decent performance, almost certainly. All right, because this is going to be the most common search operations, and it's not wrong. It's not this database sin to do partial searches. If sometimes you need to search for SON or SEN because you couldn't remember which one it was, that is perfectly acceptable, right? You have that capability. The language lets you. You're just going to have to go touch every single row in the entire data structure that you're scanning. And that's okay, right? It's what the customer needs. You can't capture every last one of these situations. You can't optimize for every one of them. If you find people are typically by profiling and seeing what's being used, if you find they're searching for the last 3 characters of people's names constantly, add another column, which is the last 3 characters. Make it a computed column that substrings the last 3 characters of names and indexes them. Totally acceptable. So if you commonly need to search for the whole name in this particular case, or just certain characters, use a concatenated column, a calculated column, and persist it, index it. You can do all that. You can search on those and index on the last 3 columns. You can do a reverse. You can do all sorts of things and make an index on that value. And it's totally good stuff. All right. So first number form is very performance oriented. I mean, it's also good for data integrity. having to put in the first name and last name as individual parts does help with integrity, and suffixes and all the pieces, or breaking into individual columns, individual rows, if that's the case. But it's very performance oriented because that's how indexes work. Indexes work with these scalar atomic values, scalar being a single value, and then atomic being an atomic, as we said, that atomic value having the single value in that scalar value, as opposed to like a table or an array. Indexes work on the whole values really well. More tables, I hear people say things like, there's too many tables, it's going to be slow. More tables are actually decent because there are more things you can more places you can index, more clustered indexes. Anywhere you can cluster on a value you're going to use and join to, the better. Not having to dig into a structure to get a value that doesn't fit in that structure becomes far harder than having two tables and joining them. I don't mean it's going to be easier for you necessarily. Sometimes having a bunch of tables does feel harder because you've got to do more joins, but not having to dig into a structure and fetch pieces out and get it right is actually typically going to be easier pulling from the structure. Now, if you look at the bottom of the screen here, yes, I could put Joe into the table with each character. There are reasons to do that, okay? But that's not the typical reason. Don't think of these rules as rules for the architect to solve the world's problems. Think of these things as tools for the architect to do what the customer wants. And that is 100% your job. Totally, okay? Or again, not your job if you don't want it to be your job. That's between you between you and the job market, honestly. All right, until next time. Correctness starts with a proper structure. Once you've got here, you're really in a good place in terms of your structure doing what you expect it to do. Even data warehouses, even with their structure that we'll talk about someday, if you don't already know about them, they don't follow the next rules at all. They just throw them out and they go a different path for performance of reading only. Normalization rules we're going to keep talking about are there for optimization of writing, for data correctness, and performance. But it's a balance of those things, and with data correctness typically being number one thing that you want to deal with. Indexes were sorted data, and indexes work best with entire values. They don't work only with entire values, but best in the data, because some things like numbers you can't do that, right? You want to look for things between 1 and 10 that they're not entire values, but equals 10 is better than anything otherwise. All right, so we abruptly end. I hope you've enjoyed this. If you haven't, there's places here to reply anytime you want. Email me at drsql@hotmail.com, message me on Twitter, go to my webpage, find me on the link tree. I will add a episode to discuss or reply directly. And I'm this close to, if I get enough followers, I want to try to start a live stream once in a while and talk about anything anybody wants to talk about. And I'll put you on camera if you want. I can have 10 people at a time. I'll see if I can have some guests. I don't know. We'll see. We'll see if anybody replies to that. Anybody sees this here. That's all those get to be a little more work, but they're kind of fun too. So until next time, bye-bye.